Good morning, students. Are you feeling any difficulty between ellipse and hyperbola? And do you feel it difficult to remember the formulae of ellipse and hyperbola? Then this video is for you. See, this is ellipse and this is hyperbola. So the equation of the ellipse in its standard form is x square by a square plus y square by b square is equals to 1. Here this is x square by a square minus y square by b square is equals to 1. So this is of this form. The diagram for this is this, and A dash are the vertices, S dash are the foci, L equals to 0, L dash equals to 0 are the directrices. So here vertex A comma A dash is equals to plus or minus A comma 0. Center C is equals to 0, 0. Foci S comma S dash is equals to plus or minus AE comma 0. And equation of the directrices is equals to X is equals to plus or minus A by E. So the diagram for this is this. So A dash are the vertices, S dash are the foci, L dash equals to 0 and L equals to 0 are the directrices, and C being the center. Here this C is the center. The same here also the vertex vertices A comma A dash is equals to plus or minus A comma 0. Foci S comma S dash is equals to plus or minus AE comma 0. Directrices this and this, X is equals to plus or minus A by E, and the center C is equals to 0 comma 0. So if S comma S dash are the foci, then here S dash P minus SP, S dash P plus SP is equals to 2A. So the summation of the distances from foci is constant. Here S dash P minus SP is equals to 2A. Here the parametric points are A cos theta, B sin theta. So that means parametric equations are X is equals to A cos theta, Y is equals to B sin theta. Here the parametric points of hyperbola is A secant theta, B tan theta. This is said to be the parametric point, while X equals to A secant theta, Y is equals to B tan theta. So here equation of the ellipse at Cartesian point Px1 y1 is s1 equals to 0. That means xx1 by a square plus y1 by b square minus 1 equals to 0. Here the equation of the hyperbola at parametric point is equation of the hyperbola at the Cartesian point at p x1 y1 is s1 equals to 0. That means xx1 by a square minus y1 by b square minus 1 equals to 0. So here the equation of normal at the parametric point at the Cartesian point is a square x by x1 minus b square y by y1 is equals to a square minus b square. Here equation of normal at the Cartesian point is a square x by x1 plus b square y by y1 is equals to a square plus b square. Here everything is minus. A square x by x1 minus b square y by y1 equals to a square minus b square, while a square x by x1 plus b square y by y1 equals to a square plus b square. Everywhere plus you can see here. And here the relation between a, b and e is b square equals to a square into 1 minus e square, while here b square is equals to a square into b square minus 1. Here the eccentricity is equals to bigger square minus smaller square by bigger square. Here the eccentricity E is equals to a square plus b square by a. The diameter circle is the locus, the point of intersection of perpendicular tangents. The point of intersection of perpendicular tangents to the ellipse lies on a circle called director circle. So its equation is x square plus y square is equals to a square plus b square. That means this is the ellipse. This is the ellipse and this is the circle. So this circle is formed by the perpendicular tangents. That means, so this perpendicular tangent and this perpendicular tangent. So these are the this is the tangent and this is the tangent and these two are perpendicular. So the point of intersection of this perpendicular tangent, the locus of all the point of intersection of the perpendicular tangents lies on a circle called the director circle. So here the point of intersection of the perpendicular tangents to the hyperbola lies on a circle called the director circle, and its equation is x square plus y square is equals to a square minus b square. That means this is the hyperbola. So this is the circle here. This is the circle, and this circle is said to be the director circle, and this director circle is formed by the point of intersection of the perpendicular tangents drawn to the hyperbola. So this line is the tangent to the hyperbola and this line is the tangent to the hyperbola. So these two are perpendicular to each other. So the locus of this point of intersection of the perpendicular tangents is a circle, and that circle is said to be the director circle for the hyperbola. So as far as hyperbola is concerned, the director circle is x square plus y square equals to a square minus b square, while for the ellipse x square plus y square equals to a square plus b square. This plus and here minus are the only difference. And the auxiliary circle, so auxiliary circle has got two definitions. The circle described on the major axis of the ellipse as a diameter is called auxiliary circle. Auxiliary circle. So, for example, this is the ellipse. This is the ellipse. So the circle formed. This is the circle. So this is the circle. For this circle, till has the diameter, which is the major axis of the ellipse. So this is said to be the auxiliary circle, and the equation of this is x square plus y square equals to a square. Here the auxiliary circle is same, x square plus y square is equals to a square. The diagram for which is this. This is the hyperbola, and the circle described on the transverse axis of a hyperbola as the diameter is called the auxiliary circle. So this is the major axis of this hyperbola. So this circle is formed whose diameter is the transverse axis of the hyperbola. So this is the definition number 1. And the definition number 2 is because of the feet of the perpendiculars drawn from either of the foci to any tangent lies on a circle called the auxiliary circle for both of them. So this is the difference between the ellipse and the hyperbola. There are few things which are special to the hyperbola is the concept of conjugate hyperbola. The conjugate hyperbola in which the transverse axis is the conjugate axis and the conjugate axis is the transverse axis. Actual hyperbola. So A dash is the transverse axis and B dash is the conjugate axis. So this is the hyperbola. Its equation is x square by a square minus y square by b square is equals to 1. So the hyperbola whose transverse axis is the conjugate axis and conjugate axis is the transverse axis. So this is the hyperbola. So this diagram is the conjugate hyperbola. Conjugate hyperbola. And its equation is x square by a square minus y square by b square is equals to minus 1, or y square by b square minus x square by a square is equals to 1. Here this is a dash and this is the center. For this hyperbola, the transverse axis is the conjugate axis of the hyperbola. So this is said to be the conjugate hyperbola. For this, b square is equals to a square into e square minus 1. For this, a square is equals to b square into e square minus 1. So here e is equals to square root of a square plus b square by a square. But here e is equals to square root of a square plus b square by b square. So if e comma e dash, so let us suppose that if e is the eccentricity of the hyperbola and e dash is the eccentricity of the conjugate hyperbola, then it is connected by the relation 1 by e square plus 1 by e1 square is equals to 1. So if eccentricity of the hyperbola is given and if we are asked to find out the eccentricity of the conjugate hyperbola, then 1 by e1 square is equals to 1 minus 1 by e square. From this e dash we can get easily. So this is the conjugate hyperbola. And the next concept is the rectangular hyperbola. So hyperbola in which the transverse axis and the conjugate axis is the same, then such kind of a hyperbola is said to be the rectangular hyperbola. B square is equals to a square into e square minus 1. Here the transverse axis is equals to the conjugate axis. So the length of the transverse axis is 2a. The length of the conjugate axis is 2b. From this, a is equals to b. So substitute here. B square is also a. So a square is equals to a square into e square minus 1. So a square and square gets cancelled. So 1 is equals to e square minus 1. So e square is equals to 1 plus 1, 2. Therefore, e is equals to root 2. So e is equals to root 2 is the eccentricity of the hyperbola, of the rectangular hyperbola, and its equation is x square by a square minus y square by b square equals to 1 is the regular hyperbola. The hyperbola in its standard form. Here a is equals to b. So x square by a square minus y square by b square also, if I take it as a square, then x square minus y square by a square equals to 1. Therefore, x square minus y square is equals to a square. So this is the equation of the rectangular hyperbola. And the next concept is the asymptotes. The tangents of a hyperbola which touches the hyperbola at infinity is called the asymptotes of the hyperbola. That means, let us suppose that this is the hyperbola. So, let us suppose that this is the tangent to the hyperbola. So this tangent touches this hyperbola at an infinite point. So then such kind of a line, straight line, is said to be the asymptote. So the same thing is like here also. So this is also said to be the asymptote, and this asymptote touches this hyperbola at somewhere one point which is at infinity. So these two lines are said to be the asymptotes. So the equations of these asymptotes is x by a plus y by b equals to 0 and x by a minus y by b equals to 0. The combined equation of the pair of asymptotes are x by a plus y by b into x by a minus y by b equals to 0, x square by a square minus y square by b square equals to 0. So we can observe that the hyperbola is of the form x square by a square minus y square by b square equals to 1. X square by a square minus y square by b square equals to 1. That means asymptotes and the hyperbola are differed by a constant. That is point number 1. And the asymptotes are always passing through the center of the hyperbola. And the third one is, for example, this is asymptotes minus 0 equals to 0. This is, for example, h. X square by a square minus y square by b square minus 1 equals to 0. And the conjugate hyperbola is x square by a square minus y square by b square equals to minus 1. So this is x square by a square minus y square by b square plus 1 equals to 0. So h plus c is equals to 2a. So hyperbola and the conjugate hyperbola, if we add, then we'll get 2 times the asymptotes. So this is, if you add, these two gets cancelled. So 2 into x square by a square minus y square by b square is what we are getting, and that is the asymptotes. And the next observation that we can see here is any line which is parallel to this asymptotes. For example, this is the line. This line is parallel to the asymptotes. So cuts the hyperbola at one and only one point. And the next concept is these asymptotes are equally inclined with the coordinate axis. And the angle between the asymptotes is theta is equals to 2 tan inverse b by a or 2 secant inverse e. And the distance between the foci is 2ae. So the distance between the vertices of hyperbola is 2a. The distance between the directrices is 2a by e. So this is the hyperbola. This is center a dash, a vertices, foci, s dash, foci. So L dash equals to 0, L equals to 0, the directrices, and these two are the foot of the directrices. So this is the center 0, 0. This is a comma 0. This is minus a comma 0. This is minus a comma 0. This is a comma 0. And this is a by e comma 0. And this is minus a by e comma 0. Then the distance between a dash is equals to, this is a and this is a, so this is 2a. And the distance between the foci, so ss dash, cs is ae and cs dash is ae again, so 2ae. and the distance between the directrices is 2a by e.